Right now, a lake the size of a small sea is disappearing from the face of the earth. Not slowly, not gradually. 70% of it is already gone, and what it left behind is not empty sand or harmless salt flats. It left behind poison. Arsenic, mercury, and lead, baked into a dry white crust stretching across 400 square miles of exposed lakebed, sitting in the open air, waiting for the wind. 2.5 million people live directly downwind, and the wind never stops blowing. Great Salt Lake was not always dying. For 14,000 years, since the last ice age drained the prehistoric megalake called Lake Bonneville into the basin below the Wasatch Mountains, this body of water was one of the most extraordinary ecosystems in the Western Hemisphere. At its peak, it covered over 3,000 square miles. It was larger than the state of Delaware, larger than Rhode Island. A shallow, saline inland sea that existed long before any human being set foot in Utah, fed by 3 major rivers and sustained by snowmelt pouring off mountains that scraped the sky. 10 million migratory birds pass through it every single year. Eared grebes, American avocets, and Wilson's phalaropes came from as far as South America and Siberia, converging on this lake because it was one of the most productive feeding grounds on the continent. Brine shrimp filled the water in numbers beyond counting. The lake supported an entire biological pyramid, and at the base of that pyramid was water. Water that is now gone. The decline did not happen overnight, but the numbers tell a story of accelerating collapse that should have triggered emergency action decades ago. In 1987, Great Salt Lake reached its modern recorded high water mark. The surface sat at 4,211.6 feet above sea level. Then the diversions began in earnest. The Bear River, the Weber River, the Jordan River, all 3 of the lake's primary inflows, were increasingly siphoned off for agricultural irrigation and municipal water supply as Utah's population exploded across the Wasatch Front. By 2022, the lake had dropped to 4,188.5 feet. That is a fall of over 23 feet in measured elevation. Surface area collapsed from roughly 3,300 square miles to under 1,000 square miles. More than 70% of the lake's total volume had simply ceased to exist. Scientists at the Utah Geological Survey described the rate of decline as unlike anything in the lake's recorded observational history. The lake was not receding, it was vanishing. And underneath that vanishing water, something had been waiting for exactly this moment. The lakebed of Great Salt Lake is not clean sediment. It is not natural desert sand. It is a century of industrial and agricultural contamination, slowly concentrated by evaporation into one of the most toxic surface deposits in the American West. Copper smelting operations on the lake's southern shore ran for over 100 years, depositing arsenic, lead, and cadmium directly into the water and the sediment below it. Agricultural runoff carried selenium and mercury into the lake across the same period. While the lake was full, that contamination stayed submerged and sealed. The water locked it down. But as the shoreline retreated, year by year, acre by acre, those sediments dried out and surfaced. University of Utah researchers testing the newly exposed lakebed found arsenic concentrations reaching 380 parts per million in certain areas, nearly 8 times the federal soil remediation threshold. This is not a contained hazard zone. It is not a fenced industrial site with warning signs and restricted access. It is an open expanse of poisoned earth, stretching across hundreds of miles with no barrier between it and the atmosphere above. The mechanism that turns a dry lake bed into a public health catastrophe has a name: aeolian dust transport. Wind picks up fine particulate matter from exposed playa sediment and carries it horizontally across the landscape in clouds that can travel hundreds of miles from their origin. The world has watched this process destroy communities before. Owens Lake in California was drained in 1926 to supply water to Los Angeles. Within years, the exposed lakebed was generating toxic dust storms that blanketed nearby towns with particulate matter containing arsenic and cadmium. The California Air Resources Board eventually classified it as the single largest source of particulate matter pollution in the United States. It took over $2 billion and decades of remediation efforts to partially control it. The Aral Sea in Central Asia was drained by Soviet irrigation projects beginning in the 1960s. Today, communities surrounding the former shoreline suffer some of the highest rates of throat cancer, esophageal cancer, and respiratory disease on the planet. Dust storms carrying salt, pesticide residue, and toxic sediment from the exposed seabed are now a permanent feature of the regional climate. Great Salt Lake is walking the same road. The dust events have already started. In 2022, a wall of dust originating from the exposed southern lakebed swept across Salt Lake City, dropping air quality indexes into hazardous territory. Scientists called it a preview, a trailer for the feature film. Salt Lake City sits fewer than 15 miles from the eastern shoreline of the lake. The Wasatch Front communities include Salt Lake City, Provo, Ogden, and West Valley City. 2.5 million people live in one of the fastest growing metropolitan corridors in the United States. They occupy a valley that acts as a natural funnel for wind traveling off the lake. When those winds pick up dust from the exposed lakebed, they do not disperse it across open desert. They deliver it directly into one of the most densely populated urban basins in the American West. Utah already struggles with some of the worst wintertime air quality in the nation due to temperature inversions that trap pollution in the valley. Add a collapsing lake generating toxic particulate dust, and scientists at Brigham Young University warn the health consequences could be catastrophic. Childhood asthma rates in Salt Lake County have already been climbing year over year. Emergency room admissions for respiratory distress spike measurably on high dust days. Arsenic is a Class 1 human carcinogen. There is no safe level of chronic arsenic inhalation. The economic consequences are already visible. Property values within visible distance of the retreating shoreline have begun falling. The brine shrimp harvesting industry, once worth $60 to $70 million annually, has collapsed as salinity levels in the shrinking lake exceeded what the shrimp can survive. Mineral extraction operations are scaling back. Tourism, built around the lake's unique ecology, is evaporating alongside the water itself. The science behind the collapse of Great Salt Lake has been available for decades. The warnings have been issued repeatedly, clearly, and with increasing urgency. In 2023, a landmark study led by researchers across multiple Utah universities described the lake as being in a death spiral and called for an emergency injection of an additional 2.5 million acre-feet of water per year just to stabilize it. That water exists. It flows out of Utah in agricultural diversions every single year. Much of it used to irrigate hay and alfalfa crops that are themselves partially exported overseas. The political will to redirect even a fraction of it back into the lake has been strangled by decades of water rights law, agricultural lobbying, and a legislative culture that treated the lake as a resource rather than an infrastructure system, holding 2.5 million people's air supply together. Emergency legislation passed in Utah in recent years has allocated additional funding and water commitments to the lake. But scientists who study the system say the measures, while meaningful, fall significantly short of what the lake's trajectory demands. Every year that passes without sufficient inflow is another year the lakebed grows. Another year, the toxic crust expands. Another year, the dust has more territory to work with. The Great Salt Lake will not send a warning before it crosses the point of no return. There will be no single catastrophic event, no earthquake, no eruption, no moment of sudden rupture. There will just be a morning when the last measurable depth gauge registers a number that represents a system too shallow, too salty, and too diminished to sustain the biological and hydrological functions that made it a lake in the first place. Scientists who have studied the lake's sediment record know what a dead Great Salt Lake looks like. It has happened before in geological history. What remains is a salt flat. What follows is dust, permanent, unceasing, chemically contaminated dust blowing across a valley that 2.5 million people call home. The arsenic in that dust was not put there by nature. It was concentrated there by a century of industrial activity and preserved there by a lake that is no longer deep enough to keep it submerged. The people who will breathe it built the cities that drank the rivers dry. And right now, on the exposed western shore of what was once one of the greatest lakes in North America, the white crust stretches further than it did yesterday. The wind is already moving across it, and the dust is already in the air.